Good evening, ladies and gentlemen. I am very thankful to the conference organizers of 22nd International Conference on Environmental Indicators for the arrangement of such a nice platform and for inviting me for a talk here. Thank you very much. The title of my talk is Cadmium Remediation Potential of Linseed in association with plant growth promoting rhizobacteria isolated from industrial wastewater. So yesterday night I spent some time to introduce myself. So I prepared one slide for that. As you can see, my name is Tariq Javed and I am Assistant Professor of Botany at Government College University, Faisalabad in Pakistan. Here you can see the city, Faisalabad. It was designed by the British. You see the British flag here. You can see the city center here. They have the city center has 8 streets, just like the map of the British. You see the city center, there are 8 streets. So it was designed by Sir James Lyell, and it was named Lyellpur since 1979. And after that, after the name of the Saudi king, Shah Faisal, they changed it to Faisalabad. So now it is called Faisalabad. So this is the university where I am working. And I did my doctorate from Stockholm University in 2011. Here you can see me at the City Hall. And here you can see me with my professors, Professor Margaret Rigger and Professor Sylvia Lindbergh. So that I did last night, because I just realized that the conference, the session chair will be tired enough in the evening to introduce me, so I prepared myself. So coming to the contents of my talk, I will talk about a little background of my talk, and then I will talk about cadmium as well, and what is phytoremediation, how that can be assisted with PGPR, plant growth promoting rhizobacteria. I will talk about linseed as well. So I will talk about the aims and objective, experimental layout, and towards the end I will talk about my results and some conclusions I have. So cadmium is a heavy metal having a density of 8.65 gram per cubic centimeter. In non-polluted soil solution, it is 0.04 to 0.32 millimolar. But in polluted soil, it ranges from 0.32 to 1 millimolar. Its major sources are mostly anthropogenic. The evidence coming from evolutionary plant biology indicates that it's a totally anthropogenic sources from where the cadmium is coming to the environment. It is coming from the burning of the fossil fuel, metallurgical industries, phosphate fertilizers, and the sewage sludge. And cadmium has had no known function in biological system, particularly in plants. There is only one report in 2004 where it is stated that the cadmium can replace zinc in carbonic anhydrase, and that enzyme can function, still can function well. There is no confirmatory report after that, so far no known function of cadmium in plants. So it's highly toxic, it's readily soluble in water, that's why it's highly mobile in soil plant systems, highly toxic. It is recognized as an extremely significant pollutant, meaning that since the metal is cationic, it can bind to the soil particles which are hanging in the air, I mean dust particle, then it can be transferred to long areas. So it doesn't matter whether it is produced in China or Southeast Asia, somewhere else, it can be transported to Europe as well. So that's why I said it is a significant pollutant. It's not only transporting by water and soil, it is also transporting by air. So rhizospheric cadmium ion adversely affect the plant growth and physiology. That is my conclusion about the cadmium. So it affects the plants in different ways. It destroys the lipids and proteins in the membrane and causes lipid peroxidation. It results in the formation of reactive oxygen species and disturb the biological membranes and so on. So it is taken up by the root hairs through the root epidermis by a plastic pathway passing through the endodermis, cortex, and endodermis, and is filtered at the Casparian tip. And after the Casparian tip, it enters into the symplastic pathway, and then it is translocated, loaded into the xylem and phloem, and go into the upper plant parts. So phytoremediation is the way by which different pollutants can be extracted from the soil and water by using plants. This technique is rather environmental friendly, it has low cost, but in most of the cases it works when the level of pollutants in soil and water is rather very low, so that the plant can function well. So there are different types. If the plant are extracting a lot of heavy metal, it will be called phytoextraction. And if the plants are stabilizing it in the soil, it will be called phytostabilization. And sometimes the plants can volatilize the heavy metal. So there are different other categories, for example, rhizofiltration and so. So I have chosen to isolate these PGPR, plant growth promoting rhizobacteria, from the industrial wastewater and to apply linseed to assist the plant to take up more cadmium. So the efficiency of phytoremediation can be enhanced with the assistance of plant growth promoting rhizobacteria, because they can transfer the metal into bioavailable and soluble forms through the action of phytosterophores, organic acids, biosurfactants, and the redox processes. PGPR can also possess plant growth promoting traits. They can fix the nitrogen, iron sequestration and phytohormones, ACC deaminase synthesis, and phosphate solubilization. So I started working with the linseed. So linseed is also known as flax, or is a common flax. It's a member of genus Linum in the family Liniaceae, and it is food and fiber crop. And the textile coming from flax is known as linen. Seed also produce the linseed oil. The plant is 1.2 meter tall with slender stems, and it's mostly cultivated in Egypt. So we hypothesize that the PGPR strains isolated from the industrial wastewater will assist the linseed to grow better and take up more cadmium. So the objectives were to isolate the potential PGPRs from the industrial wastewater of Faisalabad city and to apply those to linseed for the remediation of cadmium. And we were also interested to see the physiological responses of linseed under cadmium stress when they were either inoculated with PGPR and they were not inoculated with PGPR. Overall aim was to take care of these cadmium-polluted soils. So wastewater samples were collected from Chakera in Faisalabad. I will show you the map on the next slide. And then bacterial strains were isolated and identified. I will show you. And seeds of the linseeds were taken from a research institute. They were grown with different cadmium concentrations. We choose these concentrations because they were mostly prevailing in these wastewaters and in the city. Here I am showing in the sampling site. As I explained, the city is divided into two parts. One is the eastern part, another is the western part. City of Faisalabad I am talking about. Eastern part, all the waste water of eastern part is going to one river, which is toward the eastern side, called River Ravi. And the waste water of the western side is collecting in a drain. You see this drain, which is called a hardened drain. So half of the wastewater collected in this drain is going through this treatment plant. You see, it's going through this treatment plant. Half of it is going to this treatment plant, other half is passing directly to the river Chenab. So my hypothesis was, since this place is collecting wastewater for a long time, so there must be some microbes which are metal tolerant. So with that objective, we started sampling the site. Here all the untreated wastewater is collected, and then it is going through different ponds where it's partially treated, you can see here, and then it is fully treated, then it is going again to that drain from where it was coming into this treatment plant. So half of the water goes untreated, while the other half passes through this treatment plant, and both these water then goes into the river Chenab and then goes to the irrigation stream. The problem was the farmers were more interested in untreated wastewater. They said that it has more nutrients and so and so, but at the same time, wastewater have very low pH and bioavailability of heavy metals very high. So they were growing vegetables in the peri-urban and suburban areas. So these vegetables are having a lot of cadmium, lead and zinc, and people are eating it, they're hospitalized. So the problem was to convince the farmers that they should use this biologically treated wastewater rather than this untreated wastewater. Yeah. So here I sketch how we isolate the bacteria. Sampling was done, the samples were serially diluted, spread on the diluted agar, amended with heavy metals, incubated for some time, and purified cultures were obtained by repeated streaking, and the pure cultures stored in glycerol, and the different characteristics of the microbes were checked, and the catalytic activity of the microbes were also checked. Here I was showing the phosphate solubilization and indole acetic acid production of these isolated microbes when we apply different levels of cadmium. I will show you further results on the next slide. So physiological, we isolated 21 strains from this wastewater, and you see first 4 were from the source point where untreated wastewater was collected. 5th to onward, it's an entry point because before entry they were removing some large particles, sediments and some plastic bottles and something like that. And then there were partially treated ponds, so we have collected some strains from there, and in the end we took some strain from the treated pond. And looking at the physiological characters of these isolates, we realized that these isolates which we took from this partially treated pond of Chakera, we named it CP13, it has very good results. And then we went for identification of this CP13, and we identified it as Serratia marsens. So we call it CP13. And then in our subsequent experiments with linseed, we use this CP13. And then we plan a small experiment with these plastic containers having the soil and it's growing the linseed. So we took this CP13 and we applied it to linseed with 2 concentration of cadmium. It's a 5 milligram per kg and 10 milligram per kg. And the results indicates that the CP13 inoculation improved the biomass parameter of linseed plant with and without cadmium is showing. So T4 treatment where the soil was inoculated with CP13 having 5 milligram per kg cadmium was promising. Treatment to improve the morphological attributes. And further, we were also studying the oxidative stress and antioxidant of linseed, whether they are affected by the inoculation with the CP13 or not. So here we have seen that T5, where we apply 10 milligram cadmium, oxidative stress was high, but the application of CP13 assisted to reduce the oxidative stress as well.
Mohammed, just 2 minutes left.
Yeah. And further, we were also looking at the nutrient status of linseed when the plants were inoculated with the CP13 or without. And the result shown here indicates that the plant maintained a good balance of nutrients when it was grown with microbes. And finally, we were looking into the uptake characteristics of cadmium into the roots and shoots, and we were calculating the bioconcentration and translocation factors. As you can see, the bioconcentration and translocation factors of the plants growing with CP13, these were below 1, which indicates that the metal was staying mostly in the soil, in the roots. It is not entering into the aerial parts. I mean, that was somehow opposite to our hypothesis, because we hypothesized that these microbes will solubilize and will increase the uptake. But the results were opposite, that these microbes somehow producing some organic acid, some siderophores, which fix cadmium into the soil, as one can see from these bioconcentration and translocation factors. So we made some conclusions from this work. The linseed inoculation with CP13 significantly improved the plant biomass and cadmium and metal accumulation potential, but in roots only. It's not translocating into the shoots. The linseed exhibited lower bioconcentration and translocation values, which are lower than 1, which indicates that along with having plant growth promoting characteristics, this CP13 fix cadmium somehow in the soil and prevent its transport into the aerial burden. By that way, the microbes also reduce the accumulation of cadmium into the final yield, final seed products. So overall, this efficient plant growth responses caused by the inoculation of CP13 pointed out that the inoculation lessened the metal toxicity and improved the plant growth by triggering the production of growth beneficial metabolites that we are studying right now. And we suggest the linseed grown with inoculation of CP13 suitable for phytostabilization of metal-enriched soils. And we are also publishing some of our works, similar works. We are working with Staphylococcus under salt stress in maize. And finally, I would like to thank Higher Education Commission of Pakistan for the financial assistance, Government College University for all the assistance to me to come here directly from Pakistan, my students and collaborators. And I thank you all for the attention. And if you have any question.
Thank you. Okay, I think we do have time for a question if there is one.
I'm just preparing a paper, exactly what you're doing, but with much more heavy metals, with wheat. And wheat is important because we eat. It's bread based.
Yes.
So basically what you did with the bacteria, yes, if I understood well, okay, you inoculate the roots, yes, the rhizosphere is what you're doing. Where the blood cadmium is going? It's in bacteria or it's in the plant? Because I saw your TF in back.
Yeah.
BAC.
Yes. That I don't know right now.
Sorry?
That I probably don't know whether this cadmium is staying in the plant roots or is staying in, it is stick to the root surface or it stick to the soil particles or it goes to the micro. I don't know. I was doing a lot of fluorescence microscopy during my doctoral studies where we can tag the heavy metals with fluorescent dyes. And then we can see where they're going. I am planned for that, but I haven't done that yet so far. One problem with these fluorescent dyes is, these are the acetoxymethyl esters. They do not cross the plant cell wall. They can cross the plant cell membrane. And when they go into the cell, they react with the esterases, activated and show fluorescence, indicate the level of cadmium. And one difficulty with the root cells is to remove the cell wall. It's rather easy to remove the cell wall, the cellulose and hemicell peptides in the leaf cells. But I am planning for that. to look at whether the cadmium is staying outside the cell, whether it is sticking to the negative charges of the cell wall, or is going into the cytoplasm, or staying into the microbes. So that I have in my mind, but we haven't done that yet.
Okay,
Yeah.
Okay, thank you, ma'am.